Very simple topic, which are types of linkages in clustering. See, in last video, we have learned what is hierarchical clustering is, right? See, there are two forms. One is agglomerative and the next thing is divisive. In the both approaches, first one is bottom up approach and the next thing is top down approach. So whatever the approach we are using it, we are trying to find out the distance between the two data objects into the cluster, into the data. So whenever you are trying to find out distance between the points, there involves three types of linkages. Those are single linkage, complete linkage, and average linkage. See, what is meant by single linkage? See, single linkage. See, let us suppose say you have two clusters, R and S. You are trying to find out distance, minimum distance between the data point, one data point in R and another data point in S. So you need to find out the minimum distance between the data points in the both the clusters. So that is nothing but the single linkage. Single linkage is nothing but the minimum distance between the two data points in the both the clusters are nothing but the single linkage. So linkage or R, the formula of single linkage is L of R, yes. R indicates this particular cluster, S indicates this cluster, and you're in single linkage, we are trying to find out the minimum distance, right? Minimum distance of I comma j, where I is a data object which is belonging to R, j is a data object which is belonging to S. So that is what we mentioned here. So this is what single linkage is. And what is complete linkage? And the opposite of single linkage, where the maximum distance between the two data points in the two different clusters are nothing but the complete linkage. That means that you will be considering one data point in R and the data point in S, which are far away from each other, which are having maximum distance apart from all other data points in the both the clusters. That particular distance, you can call it as a complete linkage. The formula is L of R comma S, R, N and S are the name of the clusters, is equal to maximum distance of I comma j, where I is a data element or an object belonging to R cluster and j is a data object belonging to S cluster. This is what the complete linkage, which means that the maximum distance between the two data objects in both the clusters is nothing but the complete linkage. And the last one is average linkage. The main thing is here is that we have two clusters, R and S, right? So you're trying to find out the distance between the every data object randomly. You will find out the distance between the data object in R and one data object in S. You will find out n number of distances between the two different objects in two different clusters. Later on, what you have to do? So all the differences, all the distances can be averaged. You will be doing arithmetic mean. That is what the average linkage is. So you will be doing the arithmetic mean of these distances will be calculated. So that is what here it means. L of R comma S is equal to 1 by n suffix R plus n suffix S. That means that number of elements in R cluster plus number of elements in S cluster, which is summation of I is equal to 1 to n of n suffix R, which means that number of elements in R cluster, and similarly summation of number of elements J. The elements in J cluster will be represented as J is equal to 1 to n suffix S, which is represented by number of elements or data points in S, and each and every element you are doing arithmetic mean. So that is why D of Ij. So where I is belonging to R and J is belonging to S. This is very simple topic, but it will ask you for 5 marks.